I am Madhubalan, Assistant Professor of Mathematics, Bishop Giver College, Trichy. Now I am going to discuss the topic graphs and its types. Now we are going to see some basic definitions of graph. A graph is defined as an added pair of set of vertices and set of edges. It is denoted by G is equal to V comma E. Here V is the set of vertices and E is the set of edges connecting the vertices. For example, consider the graph with 5 vertices A, B, C, D, E. Here V equal to A, comma, B, comma, C, comma, D, comma, E. Edge E equal to AB, comma, AC, comma, BD, comma, CD, comma, DE. Adjacent vertices. If x equal to U, comma, V belongs to x, then the line x is said to join U and V. The vertex U and V are said to be adjacent. For example, in this graph, U and V are a vertex since there is line joining between U and V. Adjacent edges. If two distinct lines x and y are incident with common point, then they are called adjacent edges. For example, U and V are points, x and y are adjacent lines since there is incident with common point W. Degree of the vertex. The degree of the vertex Vi in a graph G is number of lines incident with Vi. It is denoted by D of Vi. Degree of loops are counted twice. For example, in this graph, D of 1 equal to 2. Degree of the vertex is equal to 2. Number of lines incident with 2. Degree of 3 is equal to 2. Degree of 2 equal to 4. Since counted loops are counted twice. Degree of 4 equal to 2. Isolated vertex. A vertex V of degree 0 is called an isolated vertex. Next one is end vertex. A vertex V of degree 1 is called end vertex. Types of graphs. First one is null graph. Second one trivial graph. Third one non-directed graph. Fourth one directed graph. Fifth one connected graph. Sixth one disconnected graph. Seventh one regular graph. Eighth one finite graph. Ninth one infinite graph. 10th bipartite graph. 11th one simple graph. 12th one multi-graph. 13th graph pseudo graph. 14th Euler graph. 15th cyclic graph. We are discussing one by one. Now we are going to see types of graphs. First, null graph. A graph whose edge set is empty is called a null graph. In other words, a null graph does not contain any edges. For example, 3 points A, B, C are disconnected graph. This graph consists only of the vertices and there is no edges. Since the edge set is empty, therefore it is a null graph. Trivial graph. A graph having only one vertex in it is called as a trivial graph. For example, single vertex A. Here since only one vertex is present, therefore it is a trivial graph. Non-directed graph. A graph in which all the edges are undirected is called as a non-directed graph. In other words, edges of an undirected graph does not contain any direction. For example, 4 vertices and 4 edges consists of the graph. Here this graph consists 4 vertices and 4 undirected edges. Since all the edges are undirected, therefore it is non-directed graph. Fourth one, directed graph. A graph in which all the edges are directed is called as a directed graph. In other words, all the edges of directed graph contain some direction. Directed graph also called as digraph. For example, 4 vertices and 4 directions of the lines. This graph consists of 4 vertices and 4 directed edges. Since all the edges are directed, therefore it is a directed graph. Fifth one, connected graph. A graph is connected graph at least one path exists between every pair of vertex. For example, uh, here there exists at least one path between every pair of vertices. Sixth one, disconnected graph. A graph in which there does not exist any path between at least one pair of vertices is called a disconnected graph. For example, there is no edges between D and F. It is disconnected graph. It is not possible to visit from the vertices of one component to other vertices of other component. Regular graph. A graph in which degree of all vertices is same is called as regular graph. If all vertices in a graph are edge of degree k, then it is called as k regular graph. For example, three regular graphs. Here all the vertices are have a degree 2. Therefore, they are two regular graphs. Finite graph. A graph consisting finite number of vertices and edges is called as finite graph. Here 4 vertices are finite and 4 edges are finite. Therefore, it is a finite graph. Infinite graph. A graph consisting of infinite number of vertices and edges is called as infinite graph. Example, infinite number of vertices and infinite number of lines. Therefore, it is an infinite graph. Bipartite graph. A bipartite graph is a graph. Vertices can be divided into two sets, x and y. The vertices of set x only join with vertices of a set y. Example, vertices of x are a, b, c, d. Vertices of y are b, q, r. There is line joining between a and x and y. Symbol graph. A graph having no self-flows and no parallel edges is called as symbol graph. For example, here this graph consists of 3 vertices and 3 edges. There is neither self-flows nor parallel edges. Therefore, it is called as symbol graph. Multi-graph. A graph having no self-flows but having parallel edges is called a multi-graph. For example, here this graph consists of 3 vertices and 4 edges, out of which one edge is parallel edges. There is no self-flows but parallel edges are present. Therefore, it is multi-graph. Pseudograph. A graph having no parallel edges but having self-flows is called pseudograph. For example, since the graph has no parallel edges but self-flow in node A is present, therefore it is pseudograph. Euleric graph. Euler graph is a connected graph in which all the vertices are even degree. For example, here this graph is connected graph. The degree of all vertices are even. Therefore, it is Euler graph. Cyclic graph. A graph containing at least one cycle, it is called cyclic graph. For example, here this graph consists of 2 cycles. One is A, B, C, D. Other one is D, G, E, F. Therefore, it is cyclic graph. Thank you.